Leveling process of determining the elevations of given points above or below the datum line or establishing given point of required heights above or below the datum line is known as leveling. Uses of leveling: to check the levels of crane rails, to check levels of equipments, to check settlement of tall structures, to calculate stock in the stockyard of raw materials, to determine or to set plinth level of a building, to decide or set the road, railway, canal or sewer line alignment, to determine or to set various levels of dams, towers, etc., to determine the capacity of reservoir, to calculate mass earthwork quantities. Level surface is a surface normal to direction of gravity. Horizontal surface is a surface tangential to level surface. Vertical surface is surface that joining lines perpendicular to horizontal. Datum is a arbitrary surface from which elevations are measured. Mean sea level is measured average level of sea over a period of 19 years. Benchmark is a fixed point of reference of known elevation. Residual level is a height above or below the datum. Backside is a first staff reading after setting up the instrument. Foresight is the last staff reading before shifting the instrument. Intermediate sights are staff readings after taking a backside and before foresight. Change point is a point where instrument is changed. First instrument is set up at point A and backside is taken on benchmark. Then intermediate sights are taken. Afterwards, instrument is shifted to point B. From point B, backside is taken on point A. Afterwards, intermediate sights are taken before point C. Last reading is taken on point C. Main components of level: a telescope to provide line of sight, a level tube to make the line of sight horizontal, a leveling head to level the instrument. Types of levels: dumpy level, Y level, Cook's reversible level, Cushing level, tilting level and auto level. Out of this, dumpy level is mainly used recent days auto levels are being predominantly used. Types of leveling: barometric leveling, hypsometric leveling, direct leveling, indirect leveling. Barometric leveling will be done based on the atmospheric pressure at the particular point. Hypsometric leveling is boiling point at a particular point. Based on the boiling point, the level will be determined. Direct leveling is used with the help of instrument. Indirect leveling will be done by using trigonometric methods. Before taking levels, you have to make temporary adjustments to the leveling instrument. First, we have to set the tripod on the survey station and unbox the leveling instrument from the box and fix it over the tripod. Then we have to turn the instrument parallel to the 2 foot screws, and we have to adjust the foot screws such that bubble will come to the center of the instrument. Then we have to turn the instrument parallel to the 3rd foot screw, and we have to adjust. Afterwards, we have to bring back to the same position and check the center of the bubble. If it is okay, we have to turn the instrument to 180 degrees. If it is okay in that direction, we can carry forward the types of leveling: simple leveling, differential leveling, fly leveling, profile leveling, cross sectioning, reciprocal leveling. Simple leveling will be done to know the difference between 2 points. Differential leveling will be done when 2 points are away from each other. We have to shift the instrument number of times to carry out the leveling. Profile leveling will be done for laying of roads, railway lines, pipelines, etc. when distance between survey points are very long. This will help in minimizing the earthwork, etc. For balancing of earthwork quantities also, it will be useful. Cross-sectional leveling will be carried out when levels are required in transverse direction also. At every 30 meters interval, cross-sectional leveling will be done. Reciprocal leveling will be done when distance between 2 points are very long and in between we cannot access the points. In that cases, leveling will be done from both ends. This will compensate the errors due to distance. Residual levels can be calculated through height of collimation method or rise and fall method. In height of collimation method, computation can be rapid and saves labor. In rise and fall method, calculations are laborious as all station computations are required. Height of collimation can be adapted for longitudinal and cross-sectional RLs. In rise and fall method, difference of levels of 2 points where precision is required can be adapted. There is no checks on intermediate stations RLs in case of height of collimation method, and RLs of all stations can be checked in rise and fall method. Arithmetic check sigma bs minus sigma fs is equal to last RL minus first RL. In case of rise and fall method, additional check of sigma rise minus sigma fall should also equate to other parameters. Intermediate station errors cannot be checked in case of height of collimation method. In rise and fall, intermediate station errors can be noticed. Let us take an example of one illustration. The following consecutive readings were taken with dumpy level 0.86, 1.35, 2.22, 0.78, 1.05, 2.78. The instrument shifted after 4. The reduced level of benchmark is 500.00 meters. Calculate reduced levels of stations. Let us first calculate through height of instrument method. Let us tabulate the readings in a table. At station D, instrument was shifted, so there will be 2 readings at station B. First station height of instrument is 500.86. At second station, height of instrument plus difference of the levels at station D, that is 501.13. RL at A is equal to 500 meters, that is benchmark. Height of instrument at station A is 500 plus 0.86, totally 500.86. At station D, instrument shifted and 2 readings were taken at station D. Hence a new height of instrument will come into picture. Height of instrument at 2 is RL plus backside, that is 500.08 plus 1.050, that is 501.13. After completion of reduced levels, let us apply the check. Sigma backside minus sigma foresides is equal to 1.65. Last RL minus first RL is equal to 1. Let us solve the problem by using rise and fall method. At station D, instrument is shifted and 2 readings are there. From A to B, there is a fall of 0.49. From B to C, there is a fall of 0.87. From C to D, there is a rise of 1.44. From D to E, there is a fall of 1.73. Let us do the detailed calculations. From A to B, 0.86 minus 1.35 is equal to fall of 0.49. From B to C, 1.35 minus 2.22, that is fall of 0.87. C to D, 2.22 minus 0.78 is equal to 1.44 meters rise. From D to E, 0.78 minus 2.78, that is fall of 1.73. RL at point A is benchmark, that is 500 meters. RL at point B is 500 minus fall of 0.49, that is 499.51. RL at point C is 499.51 minus fall of 0.87 from previous step reading, that is 498.64. RL at point D is 498.64 plus 1.44 in rise, that is 500.08. RL at point E is 500.08 minus 1.73 fall, that is 498.35. After let us apply checks. Sigma backsides minus sigma foresides is 1.65. Last RL minus first RL is equal to 498.35 minus 500, that is 1.65. Sigma rise minus sigma fall is equal to 1.44 minus 3.08, that is the mean sea level. Earlier it was taken at Karachi when United India was there. Now it is being taken at Mumbai. Benchmarks are generally found at railway stations below the name of the station.